So over time, I kind of lost that fear of dynamic type languages, and I got very comfortable programming in those languages. But I can see how there could be people in the transition like I was maybe 15 years ago, where they're predominantly programmed in language like Java or C#, and they get really worried if they have to use a language which is dynamically typed. So for a lot of those people, TypeScript really gives that relief. They're able to program in JavaScript without programming in JavaScript. So this is like touching it, but you got really thick gloves on you to touch it, so you don't have to put your direct fingers on it, so to say. But which is really the point to really think about. So when it comes to languages like TypeScript, TypeScript is actually a superset of JavaScript. So essentially, you can do everything you do in JavaScript, you can do in TypeScript. But it's a superset because there are things you can do in TypeScript that you cannot directly do in JavaScript. But of course, keep in mind that the code you're writing in TypeScript actually compiles down to JavaScript. So as a result, what you are writing gets translated to JavaScript. And so at the end of the day, it limits what you can do in language like TypeScript. So whatever you do in TypeScript has to map over to what's possible, what's available in a language like JavaScript. Keep that in mind. From that point of view, I want to think about languages a little bit differently. So when it comes to languages, we often talk about static versus dynamically typed languages, if you will. So essentially, we have a statically typed language. You can say statically typed languages versus you can say dynamically typed languages. But as it turns out, this is not just only the distinction that you normally draw. So for example, if you were to think about it a little bit differently, you can lay out the x-axis, if you will, and obviously you can talk about a statically typed language on one side to maybe dynamically typed languages on another side. So we all are used to languages that are either statically typed or they are dynamically typed. So what is a statically typed language? A statically typed language is where the compiler verifies the type of the code in the code, and if the type doesn't really make sense, you're going to have a compilation failure. So a lot of languages fit into statically typed languages. Dynamically typed languages are languages where either the compiler doesn't verify the type, or there's not even a compiler for you to use. You just write the code and you run it as a script. So we often talk about these two distinctions quite a bit in our experience. But as it turns out, there is yet another way you want to really think about it. And that really comes down to what I like to call this as a y-axis, because when you think about it in terms of the y-axis, then we are getting a slightly, if you will, a different perspective on this one. So what is going to be along this y-axis, if you will, in terms of what we are going to be looking at. So on one, you could say this is a strongly typed language. On the other, you could call this as a weakly typed language. So this really starts, we can rethink about the nature of languages when it comes to this kind of typing. So if you think about language like Java or C#, we all clearly know that it is a statically typed language. So you can put Java here, you can put C# here, you can put C++. Well, actually, let's come back to that. So you can put Java here, you can do C# here. So these are examples of statically typed languages. However, imagine you're writing code in Java and you perform a typecasting. And when you perform a typecast, at runtime, you are receiving an object and you think that object is of a derived type. But it turns out it's not of the type you expected it to be. What's going to happen? You will get a class cast exception at runtime in Java and C#. So this is why they are statically typed, but they are also really strongly typed as well. So what is a strongly typed language? A strong typing is where the runtime will verify type sanity for you. So if you get past the compiler, the runtime will tell you, no, this doesn't seem it's right, don't do it. On the other hand, if you think of C++, we can say that C++ is a statically typed language. We all know that. But what happens in C++ if you perform a typecasting? And if the typecasting doesn't go really well, what will happen to the code at runtime? The answer is, who knows, right? Because if the casting were to happen to a wrong address, you may get a segment fault at runtime. Or if it happens to a right address but to a wrong object, you may pull the vtable for a different object, and all of a sudden, one object ends up behaving as completely a different object. Now, if you're not sure if that's true, I recommend you observe quietly any C++ programmer. And if you quietly observe them, you will notice that when they wake up in the morning, they're very anxious and eager to go to work because they have no clue what the code is going to do. So they have to go find out. So this is the nature of C++, that it is statically typed, but it's also weakly typed as well. So as a result, this is a language that's going to be like C++, where it is actually a statically typed language, but notice it's actually a weakly typed and a statically typed language. So that shifts the way we look at this in terms of the typing. Now, clearly we know languages like Ruby and Python are dynamically typed languages. You don't have compilers for either of those languages. You can write code, you don't have to say what the type is. But what happens at runtime if you were to treat an object as a wrong type? Well, if you treat an object as a wrong type, you're going to get an exception at runtime. In the case of Ruby, for example, you will get an error saying the object is of not the type you're expecting, so it'll give you that error. So languages like Ruby and Python are clearly dynamically typed languages, but on the other hand, you can see that this language is also a strongly typed language also. So at runtime, it will keep an eye on your type sanity and tell you whether the type is correct or not. On the other hand, you're not going to emphasize the type details at compile time because there's not even a compiler, so you don't really verify that at code writing time. On the other hand, if you think about JavaScript, we know that JavaScript is dynamically typed, but as it turns out, what happens in JavaScript if you use a wrong type in the language? At runtime, it may not give you an error. It does whatever it wants to do. Somebody said this on Twitter, and I think that, I don't remember who said it, but I think they said it in a nice way. They said JavaScript is weakly typed because every week I wonder what the code is doing. So that's a way to think about it, right? So it's a weakly typed language which is dynamically typed as well. So as you can see, that these languages kind of fit into that spectrum, into this coordinate, depending on the static versus dynamic, but also based on the strong versus weak typing. So that brings the question, how does TypeScript work? Well, obviously in TypeScript we specify the type, so we could claim that TypeScript is a statically typed language, and I think that's a really right claim. But what happens to code written in TypeScript? Your TypeScript code doesn't run as TypeScript. It gets compiled down to JavaScript. And once you compile it down to JavaScript, you can run it in the browser, you can run it on Node, whatever you want to do. So at runtime, you're not running TypeScript. At runtime, you're running really JavaScript. So as a result, you could argue that TypeScript is a statically typed language, so you might be tempted to put TypeScript right here. But because it is running on the JavaScript as a runtime, you would argue that TypeScript actually sits right here, much like how C++ is, that in the fact that it's statically typed, but it's also weakly typed as well. So it's a statically typed language, but it's a weakly typed language as well. So you don't really get the static typing like you get for Java and C#. You get more like a static typing like you get for C++ and C, if you will. So that's really the nature of where this really fits in terms of the static versus dynamic and strong versus weak typing and where these things fit in. So that gives you an idea of the capability of the language, but also the restrictions that it gives you as well. But having said that, though, we can talk about some amazing benefits we tend to derive from a language like TypeScript, because it has static typing, so the compiler can do some things for us. But one of the things you want to really ask is about typing. So if you were to write code in a language like Java or C# or C++, whatever that is, suppose you are saying type some variable is equal to value, well, what did you just do? You say that the variable's type is the type that you specified. But you want to really ask the question, so does it mean, does it mean that if a language is statically typed, you could say you have to say what the type is? And the answer really is no. That is not what static typing really means. Static typing really means the compiler can verify the type sanity. So I would argue the more statically typed the language one is, the less typing you have to do with your fingers. So in other words, if a language is more statically typed, you need to say the type much less, because a compiler can figure it out. So if you're saying the type over and over and over, then you are not really leveraging the static typing nature of the language. So this is a misconception among programmers, that we feel like we have to specify the type all by ourselves. That's not really true. You don't need to really spend as much time and effort saying the type, so you have to actually type less with your fingers, because the compiler is much more powerful to figure out the types. This is where type inference really comes in. So if you think about type inference, what does that really mean? So I'm going to say a constant, let's say, and we will call this as greet is equal to greet, a string is equal to, let's say, hi, and I want to print out greet right there from that particular code. So you can see that when I run this code in TypeScript, it tells us greet is hi, it displays the result for us. Now on the other hand, though, this is where we specified what the type is. So if you were to specify the type in TypeScript, you say the type after the variable name. Now you may wonder, like, why do you say that after the variable name? The reason really is you want to really think about what is really important. Now, I'm of this opinion that programmers don't write bad code because they enjoy writing bad code. I can bet you, right? Nobody wakes up in the morning and then chuckles and says, I'm going to go to work and write really nasty code today, right? I don't think anyone does that. So people don't write bad code because they love writing bad code. They write bad code because they don't even know what a good code looks like. And the reason is we've been trained very poorly. Nobody cared what variable names we gave. We throw some nonsense together. Nobody bothered to tell us, my gosh, that looks really ugly. And you're like, gosh, that seems to be acceptable. And we get really bad names for variables. But what if we have the habit of giving really good names? So their emphasis is that the variable name is more important than the type. So let's put the variable name first and the type after. So in other words, when you're typing this, if you said string, now your mind is saying, I have a string, so the variable name is less important. Now when you type the name of the variable and you said X, your conscience should hurt you, right? What does that X mean? And you're like, maybe I should give a better name for this variable, right? So that's why the variable name comes first and the type comes after. Not only that, if I were to say greet equal to 1, and I want to output the greet right now, notice that's an error. It says cannot assign greet because it's a constant. Okay, fine. Let's change that to a let for a minute. Run the code. Let's see what the error is. Type number is not assignable to type string because you said greet is of type string. You want to give a number to it. No, you cannot do that. So that makes sense, isn't it? Now I go back and you look at this code. Now, here is a way to think about it, right? Imagine a friend comes to your house. And when a friend comes to your house, you have a beautiful puppy at home. So when your friend comes to your home, do you tell your friend, hey, my friend, this is Buddy. By the way, it's a dog. Do you ever say that? I doubt it, right? Because that would be really weird. Because when they look at it, they kind of know it's a dog. I don't think they misunderstood it for a cat, right? So you don't have to say, this is Buddy, but it's a dog, by the way. So you don't say that. And likewise, you don't say, hey, come to my house. By the way, this is a human, right? You don't introduce people based on what their type is. Why? Because I think we can infer the type pretty nicely. If you show me a cat, I kind of know it's a cat. You don't have to tell me it's a cat. But on the other hand, what are we saying here? Oh, by the way, greet is a string you should know. And if you're going to do this, I'm okay with it. But you have to also define your dogs as dogs and cats as cats when people come to your house, right? So we don't do that in our communication because we are intelligent, we can infer the type. So if you were to assign, in this case, a hi to this variable, in the wildest imagination, can you know what the type of greet is? Well, it's kind of obvious. It's a string, so you know it, and the compiler knows it too. You don't have to say the type. Now, on the other hand, if I were to go back and remove this one, and I say greet equal to 1, notice what the compiler tells you. It's exactly the same error. And the error before was that the type number is not assignable to a type string, and the error is exactly the same right now as well, and that is because the compiler knows that greet is a string based on your declaration at that level. So for type inference, you have to define the type, you have to define the value, assign the value when you are defining that variable the very first time. And so by association of that value, it knows what the type is. If I leave out the type information, then it wouldn't, if I leave out the value, it wouldn't know the type information. You'll get an error at that point. So as a result, you can leave out the types when you don't need to provide the type and let the type inference take over. Now, if you are really unsure about type inference, you're like, oh my gosh, I see what you're saying, but I really like to see the type in front of me. That's okay, because that only means that you are comfortable and used to a certain way of writing code. And the way to get better at it is just to start experimenting, playing with it, leave out the type, make the variable name very explicit, and see how it feels. And it may feel a little awkward in the beginning, but as time goes on, you get more comfortable with it, and then you can start leveraging type inference rather than type information. That becomes a lot redundant. Especially with good IDEs today, you can hover over a variable name. It tells you what the type is if you have to look at it. But on the other hand, you don't have to. When it's very clear in front of you, you can leverage that as well. So that is basically what type inference gives you, and you can benefit from it. So then the question is, how do we write a function? So I'm going to say greet name, and in this case, I'm going to say string. The type information is needed at this time. Why do I have to say what the type is? Because if you don't say what the type is, how do I know what the name's type is? So you're going to specify the type information right there. You can also specify the return type if you want to specify the return type in this particular case. And I'm going to say return. We could say, hello, and we can return the name right there. And that's what I'm going to return from this function. So now I'm going to say something like constant result is equal to greet, and I'll say world right there. And I want to print out the result like so. And you can see that in this particular case, it says hello world. Now the type of result, what is it? Well, that has been inferred. But the reason it's been inferred is because you know that the type of the function return type is a string, so we know from the assignment that it's going to be a string. But on the other hand, if you went back here and said, this is a number and I want to assign to it, that'll be an error because that's not the right type, so you cannot assign to it. But on the similar note, if you go back here and say, I want to remove the string from there as well, and you run the code, that still worked. What just happened? Well, the return type is being inferred for you automatically. So if you go back just to understand this, if you say number right there and try to run the code, you got an error again because type string is not assignable to a number because a compiler knows that greet is returning a string. How does it know that it's returning a string? Because it looks at the return and says, gosh, you're returning a string, so the type has to be a string after all, so it knows the type right there. So that is basically an example of how you can still leverage type inference in your code as well, and as a result, you don't have to be saying the type when you don't have to. But on the other hand, you can also use optional parameters if you wanted to. So maybe your requirements change over time, and they're telling us, well, when you greet, in this case it says hello, but sometimes we want to change the message you want to send. So how about really making this a bit more flexible? Well, if you want to make things flexible, it becomes easier if you're able to evolve your code in a way existing code doesn't break. So you can continue to use the existing code. You can start writing new code as well. So in order to do this, you can come down here and say, greet world, but I want to say hi maybe. And in this case, when I run the code, notice we got an error. It says you cannot do that. Why? Because you're trying to send two arguments in this case. And of course, I need to call this as result 2. You're sending two arguments in this case when only one argument is expected. So what I can do here is I can go back and say message, which is a string. Unfortunately now, when you run the code, you can see it doesn't work. Line number 5 is broken. And line 5 says, you need to give me two arguments. You gave me only one, which means existing code is broken. So you're kind of stuck here. Either the old code will work or the new code will work, but not both. And you got to change one or the other. So how can you move forward without breaking either one of them? Well, one approach you could take is you can mark it as optional. So when you put a question mark next to a variable, that's not a different variable. It's just you're coloring that variable to say that variable is optional. You're not required to specify provide a value for that variable. And if you don't, it comes in as an undefined in your case. So if I run the code this time, it says, hello world for that one. But on the other hand, if I were to use the message now in here, so I'll say message like so, and pass that message over to it. And I want to, of course, print the result 2 as well here so we can look at the output. You can see it says undefined because you have not provided a value for it. So potentially you can say if message is defined, then you can return one value. Else you can say, I can return a different value. So in this case, if it's defined, you can use the message. If it is not, you can simply say hello, and you can do the code like that. So optional values are useful in some situations, but it still feels like the code is a bit more verbose than it should be. What can we do to eliminate that? Well, even though optional is really a good idea, you can also use what is called a default value. So a default value is where you can specify equal to hello. So you are saying, if you don't provide a value for me, I will use that value. But if you do provide a value for me, I'll use the value that you provide. So instead of using optional, you could use a default as well. So when I run this code right now, you can see the value is hello if you don't provide it, and a hi if you provide. So that can be really powerful as well. Then if you're kind of wondering at this point, do I need to specify the type over here? The answer is no, because now it has enough context to find out what the type of message is, because you assigned it to a string, so it knows that it's a string. So if I were to come back here and say result 3, and if I were to send a number here rather than a string, you will notice that it gives you an error, because you are allowed to give a string, not a number. So type inference can be leveraged there as well, if there is enough context for us to figure out. So that's an example of using an optional type versus a default value as well that you can use pretty effectively. Now, so with all this said, it streamlines how we are writing functions, how we are using them, but it also gives you that nice way to perform type verification at compile time as well, even though this is literally compiling down to JavaScript. If you're just curious, what does it look like when it is compiled down to JavaScript? So let's take a look. If I want to take this one, notice it's got a name string and return type is string and all those good stuff. But if I were to go back here and say tsc sample.ts and compile that down to JavaScript, that's a JS file, you can see that's a JavaScript it created right there under the hood, and you can see the type information is not there, and you can also see how it is checking the value when it's an optional and verifies with it. But of course, JavaScript now has default values as well. So when you compile your TypeScript, you can even target it to a version of JavaScript. So that way it might use a more recent version. So rather than using var, it can use a const as well. So you can ask it to target to a particular version of JavaScript as well. And you can play with it nicely where that would make sense. So that gives you an idea how that compilation actually works as well. So that takes us to one other concept I want to quickly talk about, overloading, before we talk about REST. So there are times when you might really want to create something a little different. For example, I may say I have a function called log, which takes a value, which is a string, and all I'm going to do is simply say logging, and let's simply say the value that we received right there. So I can call log and send hello to it. So as you can see in this particular case, that's going to call logging and hello, so that worked really well. But what if I want to call log and I want to pass a value of 1 or a value of, let's say, 1.2 or 1.3? Well, clearly that will not work because that's not the type that is expected. So what do you do if that is the case? Well, what you can do is you can, with some limitations, you can do overloading. So you can say number, and you can ask it to accept a number as well, as you can see in this particular case. And you can say that I will accept a number in addition to accepting maybe a value, which is a string as well. You can ask it to provide it. So you can ask it within reason. You can ask it to use overloading of functions. And of course, JavaScript doesn't allow overloading. So you may have to declare that function to say you got a different types in here that you are willing to accept, and you can provide that scenario. You can look up the syntax for it, but gives you a little bit of flexibility. But that brings us to the REST parameter, and what can you do with the REST? Well, before the time of the REST introduction of the REST feature in JavaScript, we really struggled to use a variable number of arguments. For example, think about function like a printf in a case of C, or even printf in Java, for example. You can send variable number of arguments to that particular function. You can send 1, 2, 3, 4, any number of arguments. But how do we support that? Well, as it turns out, what's really wicked and weird is in JavaScript, you already had the ability to pass a variable number of arguments. You can pass any number of arguments to a function, and that's not limited by what you define as a signature of a function. Now, that worked really well in JavaScript because JavaScript was very dynamic. But in the case of TypeScript, you are verifying the number of arguments you are passing, so you cannot really pass variable number of arguments so easily. So how do you deal with it? Well, it turns out in this case, thankfully, the feature in JavaScript, a newer feature in JavaScript, also works better for TypeScript as well, which is called the REST parameter. So for example, I can write a function here where I can say name, which is a string, but I want to say others, which is a string array that I want to receive. So in this case, a name is a required argument, but you can look at others, and that can take 0 or more number of arguments. So you can say, you can send 1, 2, 3, and 4, or any number of arguments. However, unlike having to pass an array, you can pass them as discrete values, and they get wrapped into an array automatically for you. So in this case, let's go ahead and print out, let's say hello, and I want to say name, and then maybe a blank, and then we'll say others.join, and we will join with a space, and we will simply print it out. So in this example, as you can see, we have this name and others we want to pass in, and we are bringing in the string that we want to use here as well in as a value. So when you look at this one, it's identified, it's expected, it says on this one. Let's see where that's coming from. So I want to call this one, I want to say, a greet is the function name, right? I totally forgot about that. So that's a function name we want to call right there. So now I can say greet, will say Tom like that. And you can see it says hello Tom, because we just gave one value. But you can also say Tom, comma, Jerry as a value here as well. And in this case, you can see Tom and then a space and a Jerry. But you can also say over here, maybe I'll say a Spike over here. And maybe I'll also send maybe one more value. We'll say Butch. And you can see in this particular case, you can have these different values being passed in as a variable number of arguments as well. So that becomes a string array, but the values really are part of this REST parameter. So when you take these discrete values and send them, the discrete values can be passed in for a REST parameter. But you may say, okay, but what if I have a constant names is equal to, let's say a Joe and maybe a Sarah here and maybe a Raju here as well, but I want to be able to pass that to the greet function along with maybe another value. We can say, a Bob, comma, if I say names over here, what's going to happen? Well, you can see there's an error. Why? Because it says type of string cannot be assigned to a parameter of type string. Well, that's a little confusing, right? So why is it saying it? Because you're taking a string array, that's what you have here, which is names, and you're trying to send it to others. Each value is required to be a string after all. So you could also do this. You can say 0, comma, names 1, comma, and something tells you that's not going to invite friends over if you do it that way, right? They're going to look at this and they're like frown over, and they're going to sit at a different table from you, right? Who wants to hang out if you're going to be writing such a boring code, right? So there's got to be a better way to write this code. So what you do here is, obviously that did not work, but you can use the ... here again. But what are we doing? So here's a way to think about it. In here, this is called the REST parameter. In here, this is called the spread parameter. Now that may be a bit confusing for you when you look at it. You're saying, hey dude, you put 3 dots, but you're calling it rest in one place and spread in another. What's wrong with you? Well, if I say I have a plus and I ask you what that means, you're going to say, I don't know. A plus could be a unary operator, or a plus could be a binary operator, isn't it? So a plus is both a unary and a binary operator. It depends on the context in which you use. In a similar way, what is ... Well, that could be a rest or a spread, depending on the context in which you use. So it's a rest when you use it when you receive the data. It's a spread when you send the data. Here's an easy way to remember, R and S and S. Rest when you receive, spread when you send. So it becomes easy to keep in mind whether it's a rest or a spread operator that you're actually using in that particular case. So we looked at a few interesting ideas so far. That takes us to how do we use Lambda expressions. So Lambda expressions are really arrow functions, and you can use arrow functions really nicely in the case of TypeScript as well. And you can use type information along with the details to write your lambda or arrow functions. So let's take a look at an example here. So greet is equal to name, and you can say that's going to be taking a string, and I want to return from here a hello, and then the name itself I want to be able to return from that particular function. So I can say in here constant result, which is a string, is equal to greet, and I can say world right there as well. And of course, I can print out the result in here as well, as you can see in this particular example. So we are calling an arrow function, and we define the type. So the parameter type is defined for an arrow function. However, the return type is inferred based on the context. You don't have to specify what the return type really is. But given this, of course, let's take this to the next level. I want to say constant numbers is equal to, let's go ahead and say a list of 1 to 10. I want to say list of numbers 1 to 10 here that I want to start with. But I want to be able to do some operations with it. So you can say output right there, and we can say here is my numbers dot, and you could start by doing a filter operation. So for example, you can say, I don't want to print all the values, so dot filter, and you can say given a number, which is going to be number, I would say given a element, which is a number, and I want to say, I want this to be returning, let's say, a number mod 2 is equal to 0. So this is returning for us all the even numbers in the collection. And then you can do a dot, if you will, a map, and you can say, given a number, I want to return maybe, in this particular case, a element, let's say, a element times 2. Maybe I can do a times 2 like this. So element times 2, right? Like so. So when you look at this code, you can see that you are mapping that over to a double of the value. And if you're really interested, you could go back and say reduce, and you could say in this particular case, you have a total, which is a number right there, and an element, of course, that is coming in, which is a number as well. So you can say that's a number. And what do I want to do with this? I could say element plus the number, in this case, the total plus the number you received, and you could total the values like so as well. Or you can say, yeah, but remember in the previous example when we wrote the greet, we had to specify the type of the variable, the parameter as a string. But what about here? I'm going to remove the number and run the code. I'm going to remove this number and run the code. And likewise, I'm going to remove this number and run the code as well. And all that works. Why? Because once again, you have type inference. The compiler is smart enough to say, aha, you're using filter, but filter is being used along with the numbers, which I know is a collection of numbers. And as a result, I know the type of the variable E is a type numbers as well. So you can leverage the type inference in there as well pretty effectively. So up to this point, we looked at writing functions and the fluency that we get from writing functions and so on. But this is one of the areas where TypeScript is very different from JavaScript. But before we talk about that, keep in mind that in JavaScript, you can create classes. You can create classes in JavaScript from day one, 20 years ago. But it was just barbaric back in time. If you created a class in JavaScript back in time, you created them as functions. So classes were already defined using functions, and that was hard, not intuitive, very error prone, really hard to maintain. But starting in ES6, they gave us a structure to create classes in JavaScript. So in JavaScript, you could create classes before, but you can create classes now as well, with just a better syntax, if you will, than you had before. Now, on the other hand, JavaScript doesn't have interfaces. Now, just a side story about it. Because JavaScript doesn't have interfaces, what they did was, in JavaScript, they gave us symbols. They introduced symbols in JavaScript because of the lack of interfaces. There are times you want to really know whether you're talking about my function or some other function. So how do you really attach that uniqueness? So symbols gave us that ability. But the concept of interfaces is still very valuable, still very useful, and we can benefit from that. So the good news in TypeScript is you can have interfaces. Now, if you're used to interfaces in languages like Java and C#, you know one thing. When you write an interface in those languages, an implementer of the interface must implement all of the things. So if your interface contains 7 methods, I have to implement all the 7 methods. This is one of the nice things about learning different languages. You know, as a human being, as a person, when you travel to different places, whether it's different places in the country, as diversely populated as India, or diversely populated as the world, if you go to different countries where they speak different languages, eat different food, what are the things you learn? You learn that every person in this world is surviving. And some of them are happier than others, wealthier than others, educated than others, but we all are surviving. But then you realize we all are surviving, but we all do things a little differently. And then we quickly realize there is no one right way and one wrong way. There are many right ways, and we can choose among these different options. In a similar way, when you program in multiple languages, one of the things you experience is there is no one way. So one of the things I learned back in time when I programmed in Objective-C was Objective-C has an interesting feature where you can define interfaces in Objective-C, but your interfaces can have what are called optional members. So an optional member, as the name alludes to, when you inherit from an interface, you're required to implement the required members, but you can leave out the optional members if you don't want them. Well, that feature is available in TypeScript as well. You can benefit from the optional members if you don't care about implementing everything that is in an interface. So let's just take a look at an example just to get a feel for it, if you will. So you can define an interface. You can also have optional members in an interface as well. So I'm going to say lat-lon as an interface like so. Now, lat-lon is my interface where I say lat is a number, but I'm also going to give a long, which is a number as well, that I'm going to define within this. But in here, I can say a function. We can call this a show location, and this is taking a location which is a lat-lon, as you would expect in here. So I can print out the location details, right? So location, I can say dot lat. I can get the latitude, if you will, and then plus I want to say here, actually let's use a more convenient notation here. So I want to print the lat like so, and I can then say a space, a location, and then a long as well, and I can print those two values. So what I can do here is I can say show location, and we can create in here a nice little latitude and longitude value that I really want to create. So we can say over here a latitude, and I can say a value, 84.32, comma, let's say minus 121.56, whatever value you want to specify, you can specify, like so in here. Oh, this is actually, I made a mistake, but it's a good way to express it. So it says the left-hand side of the arithmetic operation must be a type of a number, blah, blah, blah. So let's go to the 10 and see what it says. So that's not too happy with me. So I'm going to say over here, a long is the value that I want to bring in and I want to use it. So that indicates that it's a required value, right? Because if you don't specify it, it's not going to be very happy with you. However, I want to go back here and say, I have a favorite. Maybe this is a favorite place or not. So if I have a favorite right there, let's just say for our purpose, I want to create one more. Let's go ahead and say 74.23, and let's say 141.65. But I want to say this is a favorite, so I say favorite, and I'm going to say true, like so. But I don't want to provide a favorite for this. Well, this is where you can use the optional really nicely that we saw earlier. So you're not required to send the optional value. So the obvious question is, how do you know whether the value exists or not? Well, you can come back here and do the checking, but in this case, I'll simply just print it. So I can say location.favorite, and if it is there, it's going to print it. If it is not there, it just becomes an undefined, but you can do a check on it if you want to. So that kind of gives you an idea that certain members can be optional and you don't have to implement them if you don't want to. This can be really powerful because what this allows you to do is a couple of things. Now you may wonder, why would I want an interface? Well, you want an interface because in your code, you may be interested in receiving data which conforms to a certain specification. But guess what? When your program is talking to multiple web services, it's possible that one service sends you 4 pieces of information, but another service only sends you 3 pieces of information. Maybe these are 2 different versions of the web service you are talking to or a microservice you're talking to. How do you deal with the fact that there is 4 pieces in one and only 3 in the other? There is 1 piece that's missing. Well, you can declare it as optional and say, hey, if it's not there, deal with it. It becomes a lot easier to work with it as well. Which brings us to one really amazing capability, which I'll talk about. I do have to say that's one of my most favorite capabilities in TypeScript. I really respect this one because I truly believe this actually makes the code a lot more interesting for us to work with. And then that really, the concept of that is really called as structural mapping. I really wish more classes would do this. So what is structural mapping? So structural mapping is, TypeScript is very smart where, let's say you take a reference of type dog and you assign a cat to it. That's not going to work because dogs are not cats, we know that. So type verification is very useful when the types are different, right? So as a result, it's going to say, oops, that type is not compatible. However, there are times when in a statically typed language, there is only a fine line between where things are very helpful and things are not very helpful, right? For example, if let's say I appreciate having seat belts because seat belts save lives. It is insensible to drive without a seat belt on. So I definitely am a big fan of it. Now, what happens if a passenger sits on the passenger seat or a person sits in the back seat? Well, in any good car, it's going to start doing ting, 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 and say that you've got somebody on your seat, they're not wearing your seat belt. So what's the most sensible thing to do? Is to complain about it, right? That stupid car keeps dinging, right? No, the sensible thing is to put on the seat belt. But there are times when you decide you want to maybe carry something a little bit heavy, and you decide a good place to put it is in the front seat. So you put that in the front seat. It's not a human or a pet in the front seat. So you put that on the front seat. You're not worried about it flying over. So you start driving. What does your car say? It says there's a passenger on the front seat. You got to put on your seat belt. And now you're having an argument with the car, right? It's like, no, that's not a passenger. That's a cargo I'm carrying. Well, it would be nice to have that little switch that says, ding, stop that. Don't keep dinging. Or I usually say, put the seat belt around the cargo. That fixes it, right? But the point really is, there are times when you are really happy with the help being provided, but there are times when they become a hindrance as well. So with statically typed languages, one of the nice things is that the type verification really helps you a lot. But the problem is the place where it becomes a hindrance is when you have to do silly code to work around it. So imagine you received a JSON data. So your JSON data is with you on your hand, and it's got the properties that you really are interested. And you look on one side, it's JSON. You look on the other side, that's an interface. And between the two is you. And the compiler tells you, you want this object, you got to create an object first, and then populate the members of the JSON into the object. And you're like, why me? This is a boring thing to do. There's nothing intelligent. So what do you normally do? I've realized over time, programmers don't write stupid code. They invent tools to write stupid code. So now all of a sudden, about the 10th time you're doing it, what are you going to do as a good programmer? You're like, heck, this is boring. I'm not going to do this. And you do one of two things. You hire an intern, right? This is why interns are great, because you hire them from the university, they come over and they're super happy. You gave them the stupid code to write, and they go home and say, wow, this is amazing. They gave me all this code because I'm good. This is what happened to me. When I got my first job, they told me, you will maintain this Lex and Yak parser. I was super happy about it. I was like, oh my gosh, they gave me this code to maintain Lex and Yak parsing because I'm that good. After a year, I eventually came to know the truth. They gave it to me not because I was good. They gave it to me because nobody else wanted to do. So they're just waiting for the next victim they hired, and they said, you do it. And guess who did that for next 3 years? Because I was the last one to get hired on that project. So that's what happens, right? So what do? You invent tools quickly because you don't want to be doing this. Well, TypeScript says, don't really waste your time doing stupid things. We can help you through the journey so you don't waste your time. This is where a structural mapping really can come in. So if I say constant, let's say location lat lon is equal to, and I'm going to say here lat is 84.27 comma, lon is going to be, let's say, minus 124.54, let's say. So I'm going to then go ahead and print out the location at this time. So when you run the code, you can see in this particular case, let's see, cannot redeclare a block scoped variable location, and that's what it says about this. So let's go ahead and fix that in here. So I'm not sure why it's unhappy with me there. So we define the variable as a lat lon, and we are defining the values for it, right? So let's say loc for a second, and see what it wants to tell us. So essentially, in this particular case, I'm asking it to define that variable, and I'm going to print it. But the beauty is, it had no problems. But what if I don't specify the long like so? Notice now it gives me an error. Why not? Because that's not compatible. You haven't given me all the values. So as long as there are values that it's expecting, and just to emphasize it, I have a long, that's not sufficient, obviously. But if I said lat over here and specified the value here as well, you can see that it's going to be happy with it, and it gives you the value, so you can see that it's working. So that's actually the structural mapping. It's pretty darn good to figure this out. Well, in the next minute I want to just mention a couple of things here. You can use generics as well pretty nicely, and JavaScript has the concept of destructuring. You can use destructuring here as well in TypeScript. So you can destructure into an array, or you can destructure into a object type as well. So for example, if I say, for instance, let's say constant array is equal to, let's say 1, 2, and 3, and I want to say here a constant, let's say A, B, and C is equal to array, I can print out A and print out B as an example, if you will, and you can see that's working as well. Or I can destructure this into a dot, like a rest parameter, and in that case, it gobbles up everything else after that as well, and you can do that as well pretty nicely. And then finally, one concept I won't have time to cover here is decorators. I'm a big fan of decorators. Think of decorators as your annotations in Java or attributes in C#. They give you a very similar capability, so you can define your decorators, and then you can use those decorators in code, performing any repetitive task. Think of this as injecting aspects into your code in a very nice, type-safe, clean manner. That's what decorators provide for you as well. So like I said, it's a very respectable language. I like it a lot, but I like it a lot for the reasons I mentioned, not because it's statically typed, but it's because it's got some very elegant features that make coding a joy and also makes it less error prone as well. And that's what I really enjoy. Hope you found that useful. Thank you so much for your time.